This is Module 13, Example 2. In this problem, it says that a sample of people were randomly selected. They were then measured their foot length in centimeters and their height in inches. The data below is the actual sample data that was collected. So on the left side is the foot length in centimeters, and on the right side is the height of the person in inches. So Part A asks us to first copy and paste this data into the correlation and regression applet. So there I've copied and pasted my screenshot from the applet. Part B asks, based on the scatter plot, would the correlation coefficient be positive or negative? So it looks to me like in general this scatter plot tends to be increasing. So since the data tends to be increasing, we would say the correlation coefficient would be positive. Part C then asks, based on the scatter plot, estimate the correlation coefficient, and then we'll actually use the applet to get the correlation coefficient. So looking at this, I would say I'm going to estimate maybe 0.7. Now I can go back to the applet, and if you scroll down a little bit, you'll see that there is a checkbox here for correlation coefficient, so I'll select that. And it says, oh, that was a pretty good guess. R equals 0.711 is the actual correlation coefficient for that sample data. Part D then says, have the applet add in the best fit line, including the equation of the best fit line. So in the applet, I'm going to go in, and you'll see here there's a little box for show regression line. So I check that, and it adds that red regression line in. You'll see underneath it, it does say height, and it has this little hat here. So this is your y hat, height hat, equals 38.3 plus 1.03 times the length. So the other way to write that is y hat equals 38.3 plus 1.03x. So the best fit line is written here. Y hat equals 38.3 plus 1.03x, where x is the foot length of the person and y hat is the height of the person. Then asked to identify the slope and interpret the slope. So remember, equations of lines can be written y equals b plus mx, which is how we have written this. The b is the 38.3, the m is the 1.03, and m is the slope of the line. Recall then, to interpret the meaning of the slope, we first will write it as a fraction. So I've written it as 1.03 over 1. Then I recall that slope is defined as change in y over change in x. So I'm now going to relate that definition back to my fraction. The change in y over change in x is the 1.03 over 1. So the 1.03 is the change in y, and the 1 is the change in the x. I then add units, contextual units to the top and the bottom. Remember that in this situation, the y represented the height of the person in inches, and the x represented the foot length of the person in centimeters. So the change in y in the numerator is the change in the height of the person in inches. And the change in x in the bottom represents the change in the foot length of the person in centimeters. Now I want to say that in context. On the actual line, if you go over to the right 1 unit on the x, you will go up 1.03 units on the y. In context, that means if the person's foot length increases 1 centimeter, then the person's height would increase 1.03 inches. Part F then asks us to find the y-intercept. So again, the equation of the line was y hat equals 38.3 plus 1.03x. That's y equals b plus mx. The b is the 38.3, which is the y-intercept. Remember that we write y-intercepts as points. The y-intercept is always the point where the x is equal to 0. So in this case, the y-intercept is 0, 38.3. The point is written x, y. And we know x represents the foot length in centimeters, and y represents the height of the person in inches. So this point would literally mean that a person who has a foot length of 0 centimeters would have a height of 38.3 inches. Of course, that doesn't make any sense. You certainly can't have a person with a 0 centimeter foot length. Remember, what we're doing here is we're extrapolating, we're making a prediction based on the model, the equation of best fit, and we are going beyond the actual data that was observed. It doesn't make sense to take this equation all the way back to x equals 0 because you can't have people that have 0 centimeter feet. So this equation that we have here only probably makes sense for certainly this span of data from about 22 centimeters up to maybe 35 centimeters. And it doesn't make sense to go all the way back to x equals 0 and continue to use this equation. Similarly, it wouldn't make sense to use this equation up to like x equals 100 centimeters because there's not going to be any people with 100 centimeter feet either. Part G then says to find the predicted height and also find the residual for a person who has a foot length of 32 centimeters. And they tell us that we actually had a recorded data point of 32,74. Okay, so we're going to use our equation of best fit, our regression equation, our model, to try to estimate y hat value when x is equal to 32. So I take my equation, I replace the x with 32, and I pop it in the calculator. So in the calculator, we find when you plug in x as 32, we get a y hat equal to 71.26. This tells us the model predicts a person who has a 32 centimeter length foot would be 71.26 inches tall. Now, in reality, it told us there was a data point that was observed that was 32,74. That means in reality, they had a person with a 32 centimeter foot who was 74 inches tall. So there's some error there. You see that the model under predicted the height of the person. So to find a residual, we take the observed y value minus the predicted y value from our model. So in this case, the observed y value was 74 inches, and we subtract the predicted y value of 71.26, and we get 2.74. This means that our model under predicted the height of the person by 2.74 inches.